So, today we are talking about parent functions and transformations, so we are starting our official journey down transformation lane, and we are going to be masters of transforming very, very soon. It is going to be one of your favorite things, I hope, because I have a unique way of teaching transformations, a way that is so good that when I taught my wife, who is also a teacher, she said, "Why don't they teach us this way in the books?" And I said, "I don't know." Okay? So I teach it completely different from how the books want us to. Yes, my wife is a teacher. Venice Middle. She was your science teacher? Yep. So, what is a parent function? I know I used the term parent function yesterday. I didn't really accurately define it, though. I just used it, right? I wrote it on the board. A parent function, and yes, I know there's a typo here, so just ignore the typo. If you can spell the word properly, be sure to spell it properly. A parent function is the most basic function in a family of functions, meaning the one that has not been altered at all. That's what that means. The most basic function in a family of functions. So there are 4 parent functions up here. We only did 3 of them yesterday, and that's because I couldn't care less about this one. Just completely ignore that thing. We will not do anything with it. We're just going to completely ignore it. We will be working with the linear parent function, which is the straight line you see there, the absolute value parent function, the V-shaped graph, and the quadratic parent function, which is the U-shaped graph. Now, we did all 3 of these yesterday. But just to bring back that knowledge to the front of your brains, all 3 parent functions go through the point 0, 0. You mean for the absolute value and the quadratic? The quadratic? A parabola. Yeah, it's absolute value function, quadratic function. The shape of the quadratic function is called a parabola. Yeah, parabola. The next 2 chapters are all about parabolas. They're super important. Now, for the absolute value and the quadratic, that point 0, 0 has a special vocabulary name. It is the vertex. So I'm going to put a little V next to it, meaning vertex. And yesterday we saw that all 3 of these parent functions go through the point 1, 1. So not only do they go through 0, 0, they go through 1, 1 as well. Picture not drawn to scale, so I'm just going to throw a 1, 1 on there. As long as it's on the right side, we get it. There. The absolute value graph and the quadratic graph share the property that they are symmetric over the y-axis in their parent function form. They're symmetric over the y-axis, but the point is they are symmetric around their vertex, so that 1, 1 can be reflected to the other side on both of those graphs, and you just have to remember which one's a U-shape and which one is a V-shape. Now, I know that below these pictures on your papers it says some stuff about domain and range. We'll get to that later, another chapter. This one I'm not worried about it, so there's no point even discussing it, okay? We'll worry about domain and range in the future. For now, are we all comfortable with recognizing a linear function, an absolute value function, and a quadratic function? We're all cool with that? Great. So now I'm going to remind you, because I forgot to write it on my board, but it is on the calendar. Homework number 1 of the year is assigned tonight. It is on the calendar. If you click on the little thing that says homework number 1, it tells you textbook page 8. So it's out of the textbook with whatever examples I've asked you to do. But Mr. McCutcheon, I don't have a book. And you said you don't use big ideas. Right, Maya? Oh, that's not what she was going to say. Well, I posted the pictures of the textbook in Blackboard in the course materials. And it'll say homework number 1 textbook page. Maya, what can I do for you? Blackboard app, yeah. It's cramped. Okay. I don't use the Blackboard app. Mm-hmm. Well, what I can do is I can print a couple copies of that page and just like circle the questions for anybody that needs one, and I'll just hand it to you. Okay? For now. But we'll figure out that. Normally my assignments will be written on that board, so you wouldn't have to read the calendar to see the assignment. I just didn't get a chance to do it this morning. Jan, yes, sir? Well, homework should be due the very next day. Okay, so it's going to be due tomorrow. I think I'm asking you to do 6 questions tonight. I never bog down my students with homework. My goal is you spend 20-ish minutes on my work and no more at home. If you're spending more than that, we have a problem. That means you don't know what you're doing, and we need to get more practice in. Matthew M. I have not assigned that textbook to this course, so you wouldn't be able to, no. Yeah, it's on Blackboard. I put the page on Blackboard, and you guys will just do it on your own paper and drop it in a basket. I'm sorry? You should be in my Blackboard, yes. If you're in my course, you should be in my Blackboard. Are you on my Remind? Have you joined? Haven't joined my Remind either. I will double check. Okay? You good? Okay. So let's move on. Now that we got all the housekeeping out of the way. This is what the homework looks like, and this is what I'm expecting from my people. I'm expecting you to do exactly what I do. I am modeling how I want the homework done. My notes will always be modeling the homework, always. And my test questions are always going to look like the notes and or homework questions. So I'm setting you up for perfect success on the homeworks and the tests. As long as you do everything I do, you get full credit. It says identify the function family to which f belongs. F is its name. This is f of x. So Carlos, you think you know what kind of function this is? It's okay to use notes. You know. Yeah, it's absolute value. Yep, it's a V shape. No, you're working too hard. Absolute value. And the way that I always remember which one is absolute value is value starts with a V and the graph is shaped like a V. Oh, by the way, my people at home, if you want to answer a question, just pipe up and say Mr. M. If you've got a question yourself, pipe up, say Mr. M. We're all in here together, okay? So this is an absolute value function. The question says compare the graph of f, which is this one's name, see f of x, compare the graph of f to the graph of its parent function. You know what would make this easier? It would be much easier to do if you could actually see the parent function. So I suggest, and I would like, for you to graph the parent function. The parent absolute value function, just like the other ones, goes through 0, 0, goes through 1, 1, but it is V-shaped, so symmetric, so I'm going to reflect it over and do this. Now, I'm using a different color for this. If you're doing your homework in another color, awesome. You don't want to do your homework or your notes in another color? Then use dotted lines for the parent function. There. So I'll do both. We need to compare the blue graph to the red graph. What I'm asking is, what 2 things would I need to do to the red graph to get the blue graph? And to be asking for a volunteer to tell me one of those things, because this is how I'm going to learn names, not Connor. What's your name? Mason. Reflect up. Move up 1. So let's use the academic vocabulary of shift. So yes, we are going to shift up 1 unit. That is one of the things we have to do. So we would shift up 1 unit. So the red graph would have to bump up by 1 unit. We'll shift it up 1 unit, and then there'd be one more thing that I would need to do. So rather than tell me what I would need to do, just tell me, describe to me how the blue graph is physically different. Carlos? It is narrower. Yes, I like that. So we're going to say it looks more narrow. And yes, I need you to say the word looks. It does look more narrow. Perfect. That is good enough for now. Next week, we will describe what's actually going on so you don't have to say looks. But for now, you're saying it looks more narrow. Perfect. Shift it up one and looks more narrow. And the order in which you say them for now, I won't be caring about the order either right now.
Question, Mr. McCutcheon.
Yes, sir.
So our homework for this is just basically write down like observations from this particular equation?
For this one, yes. So some of the homework questions will be like this one where you just write down what kind it is and then the observations. And then the other kind of homework questions will be in the following slides as well. But yeah, just for these kinds of questions, you're just writing observations.
All right.
Pretty cool, huh? No, you're not even any work. You just describe what you see.
All right, just wanted to make sure.
Yeah, no, you're good. All righty. Let's do it again. All right. So I'll be looking out into my crowds and ask somebody to tell me what family of functions this is. Oh, Maya? It is a parabola, but what family of functions are the parabolas? The parabola is its shape. What is it? Quadratic. Yes, ma'am. So this is a quadratic function. Technically, because quadratic is for the x squared graphs, but parabola describes anything that's U-shaped. And there's more than one kind of U-shape. But yeah, it's a quadratic. It's U-shaped. And now we're supposed to compare this to the graph of its parent function. Again, I think that would be easier if we could see our parent function. So we should just throw the parent function on there too. I'll do it as a red dotted line. All three parent functions so far go through 0, 0. All three parent functions so far go through 1, 1. And the U-shaped graphs are symmetric. And so we're looking for a red dotted line. Okay. Just like the last one, I would have to do two things to this red graph to get the blue graph. Now, Carlos, I appreciate you, but I need to learn more names. So I'm just going to start pointing at people that haven't talked to me yet. And I'm going to ask them to tell me, especially if they're sleeping. He's so passed out, he doesn't even know I'm talking about him. It might be, who knows. So I need to know what two things would I have to do to my red graph. Rachel? Okay, Rachel, can you tell me one thing I would have to do to that red graph? Yes, good. So we will shift right 3 units. Perfect. Shift right 3 units. And so in your mind, you imagine that red dotted line, the red dotted curve has been shifted to the right 3 units. And then I'll like somebody to describe to me how the blue graph is different from the red graph. After it's been shifted, what else is different? What's your name, sir? What's your name, sir? Matthew S., correct? And it does look more wide. Good. So looks wider. Works perfect for me. It does look wider. And at this point, that is perfectly good for you to say. We'll be more specific about it in the future, but for now, it does look wider. So for these two, like Michael W. asked, yeah, you're really just describing things you see. He says this is confusing. Okay. Well, rather than making the statement, this is confusing, how about asking me a question? So let me ask you a question. Which part of it's confusing? The naming it? Are you comfortable with this part? Okay. Well, okay, so the dotted line, so what the dotted one I'm drawing is the parent function. So if you go back up to that table that shows the parent linear, the parent absolute value, and the parent quadratic, I'm just sketching the parent function on there. See, all three of those parent functions do go through 0, 0? Yes. I'm describing what I would have to do to the parent function to get the blue one. So I drew the red one on there because, well, I don't have the luxury of seeing the parent function on the paper like you do. For me, it's on another slide. So I drew it on there, and then, yeah, and we are literally just describing how is that blue one different? What did we do to it? So it looks like we moved it to the right, and it looks like we made it wider, and that is good enough. It's a little bit better? All right, cool. All right, moving on. Maybe. Did it see me? There we go. All right. So for this first one, there's several pieces of directions, and I need you to follow all of them to get full credit on the homework. The first one says graph g of x. So we're going to start there. First we're going to do is we're going to graph that straight line. Just like yesterday, this is in y equals mx plus b format. That -4 at the end tells you where it crosses the y-axis. The slope of this straight line can be found in front of the x, and since there is nothing written there, we know it's a 1, but it needs to be a fraction, so we'll call it 1 over 1. So we go to our y-intercept at that dot on -4 that I just made, and we will shift. We will go up 1 and right 1 because both of the ones on that slope are positive. Up 1, right 1 to right there. And connect your dots to the best of your ability with a straight line. Like that. And this one is G. So put the letter G on there somewhere so that way you know that this is the changed one. This is not the parent function. The directions say graph g of x and its parent function. So in a red dotted line, I am going to graph the parent function. On the homework, you guys will be graphing the one they gave you and the parent function. So you will be graphing today. Don't worry, you don't need graph paper. Just make the graphs as good as you can, okay? I'm not an art teacher. I don't care if you can draw or not. Just do your best. The parent straight line goes through the origin, goes through 0, 0, and goes through 1, 1, and just connect your dots with a straight line to the best of your ability. And now we make our observations. Now that we have both graphs, we make the observations and we say, what one thing, and it is one, what one thing would I need to do to the red dotted line to get the blue one? Matthew S. Matthew M. I mean. He says shift down 4 units, and that is a perfect answer. Shift down 4 units. Now, Matthew S., you also raised your hand, did you not? You didn't? Somebody else over here raised their hand. Who was it? Carlos, was that the answer you were going to say? Were you going to say shift down 4? What were you going to say? Okay. Oh, you didn't count how many? Okay, yeah. But we need to know the exact number. So this is shift down 4 units. Guess what? That was one of 2 possible correct answers. Is there anybody else in the room or in the virtual room that can see another possible correct answer instead of shifting down 4 units?
Excuse me.
Yes, what do you got?
Compared to the red charted line, the blue one looks smaller in comparison.
So it does look a little bit smaller, but imagine, no, you're not wrong about that. It does look smaller, but imagine the graph never stopped. If the graph never stopped, both straight lines would go on forever, and they would technically be the same size, so to speak.
Yeah.
So that's an illusion. And remember when I was saying looks wider, looks narrow? Those illusions are created by the exact same problem that my graph doesn't go forever. And I will describe that in more detail next week, I promise. Grace. She's going on a limb. It's okay to be wrong. Move up -4. Now we're just playing word games. Okay, I can't tell you you're wrong. Because if you go up a negative number, technically you have gone down. But that's like cheating with semantics. You're not wrong, but it's strange. Let's make life easy. Now, come on, guys. Instead of saying moving down 4 units, one more try. They are parallel, but I'm just gonna give it to you guys. I'm just gonna give it to you. Instead of taking this line and moving down 4, well, no, I can only touch the parent function. I could take this line and move it to the right 4. Oh, mine's blown. So you could have either said move down 4 units, or you could have said move to the right 4 units. Because of this fact that often straight lines can have more than one correct answer, I try not to mess with them too much. I try not to ask you to describe transformations of straight lines too much because it's confusing when there could be more than one right answer. You don't need to give me both right answers. I was just curious if we could see it. The next one. Next one is absolute value will be a V-shaped graph. I want you using the point trees. Mr. M, what if I could do it without the point tree? I go, that's great. But I'd like you using it because I'm setting you up for success in chapters 4 and 5 when the point trees will be very important to the graphing because I have tips and tricks that rely upon your usage of the point tree. So we have X and Y for our absolute value function. The first thing you're supposed to find for absolute value function, just like we talked about yesterday, is its vertex. And the vertex always goes in the middle. The way we find the vertex, quick review, the way we find the X value of the vertex is by telling me what number you'd have to plug in on the inside so that the inside equals 0. If I needed this equal to 0, Carlos, what could I plug in? If I plug in 0, I have to get 0 plus 1, don't I? But does that equal 0? I need it to equal 0. I need a subtraction of 1, so I need a negative 1. Good. Basically, whatever number is there, you use its opposite. That way you always get a 0. So it's got a plus 1 in there. You subtract 1. You give me a negative 1. The Y value of the vertex will always be the number that has been added or subtracted to the far right. But there's nothing over there. So what is the Y value of its vertex? It's 0. Good. So our vertex is at negative 1 comma 0. And yesterday, the trick that we talked about for figuring out how far to go to get your next X values, what I call the safe one so I don't have to graph decimals is, well, is there a fraction on the front? No, there's not. Since there's not a fraction on the front, just move by ones. Feel free to scoot to the right one and plug in 0, scoot to the left one and plug in negative 2. It won't matter which one you plug in. Question for me, sir? Yes, we need the inside to equal 0. Your job is to plug a number in so that when you actually do the addition or subtraction, you get a 0. So you always just tell me for example, let me just throw a quick one up right there. You guys don't need to write this, but if I said this, what number would I have to plug in so that it equals 0 in there? Plug in a positive 3. See, there you go. That's all you have to do. Good. Perfect. And that's a really important question to have answered because we will be doing a lot of absolute value graphing very, very soon. So now our job is to figure out what the Y values are at the two X values of 0 and negative 2. Now the good news is it doesn't matter which one you plug in because these graphs are symmetric. I try not to goof with negative numbers when I don't have to, so I typically just go to the right. So I'll plug in 0. So we have Y equals, and I know it's rather elementary plugging in 0, seeing what this is going to equal. Do I have to show that work? Look, for now, no, not really. But I'm telling you, I'm setting you up for success when the questions are harder. So I'm plugging in 0, and of course 0 plus 1 is 1, and the absolute value of 1 is 1. These Y values have to match because the graph is symmetric. So plot those two dots. And this one is named G as well. I'll throw a G over here. Why not? We also have to graph its parent function. So we need to graph the parent absolute value function. All three of the parent functions so far that we've learned, because there are more obviously, but all three of them so far go through 0, 0. All three of them go through 1, 1. And since this is a V-shaped graph, it is symmetric. We'll bounce that dot over here. Well, hold on. Now let's connect these with a dotted line because at home, I will be asking that you draw both graphs because that's what the directions in the book say. And then you tell me what one thing do I need to do to that red dotted line. Now, Carlos, I appreciate you, but there's many people in the room whose names I don't know yet. He's not Connor. I don't know. Yeah, oh, he's Gavin. I should have known. Okay. All right, Gavin, what would it starts with a G and ends with Avin. All right, Gavin, what would you need to do to the red one to get me the blue one? There you go. Shift left 1 unit. That's what you'd have to do. Shift left 1 unit. Good. And that's it. Yeah, we're always saying what are we doing to the parent function. And there it is. Now, I will tell you this, on my test, the directions, and there are test questions that look exactly like this picture, and they legitimately say what transformation has been performed on the parent function. And they're different colors, and usually one of them is dotted. But the most common student mistake is they tell me the opposite answer because they were telling me how to go from blue to red when it specifically asked how do you go from red to blue. So you just want to make sure that you're always describing what you had to do to the parent function. Okay? Always saying what you did to the parent function, which is why we're graphing it. Questions, comments, concerns on that one? Or are we ready to rock and roll to the last slide for the day? Last slide for the day then. Folks at home, no questions? Good. All right. Okay. This one I've named P of x, and it says negative x squared. We have to graph y equals negative x squared. Yesterday, I described to you the way you're going to handle the order of operations is by pretending the thing with the exponent has parentheses on it. And yesterday, it said negative 2x squared, and I did not include the 2 in the parentheses. That's because only the x has that exponent. So for this one, it's going to look like this. P of x equals negative x squared. And the negative sign on the front does represent a number. It's negative 1. And anytime you have a number pushed against parentheses in mathematics, you're being told to multiply. So you have two different operations here. You have an exponent and you have a multiplication. So when you plug your numbers in, you must follow the order of operations. You must use the exponent first, then you handle the multiplication. We will start with our point tree. I'm aware you could probably do it without it. I'm just driving home an idea for when the questions are harder. Just like absolute value functions, your job is to find the vertex first. And just like absolute values, we find the x value of the vertex by telling me what I'd have to plug in so that the inside equals 0. Well, x is the only thing on the inside, so what would I need to plug in? Oh, wait, hold on, I'm sorry. You have a question? Ah, there we go. He wants to know why the negative 1 is not inside the parentheses. Let me open up a different slide that has nothing to do with your class. Here we go. You ready for this? Let's describe the difference between, and instead of saying x, let me use a real number, a number that we're all comfortable with, okay? How about I say this? So let's talk about the difference. This one on the left, negative sign is inside the parentheses, and the exponent has a 2. That means multiply that thing to itself, correct? Okay, so that says negative 3 times negative 3. But when you multiply two negatives, what do you get? A positive. Now let's go over here. The order of operations on the right side says you have to do the exponent first. So you have to do 3 squared, which is this. But 3 times 3 is 9. You see, they're not the same answer. And so this is what I did was I just said like that. The 1 is just so that you know it does actually behave as a multiplication of a number. And since there wasn't already parentheses wrapping around that negative sign, we don't wrap that negative sign with parentheses. Only the x gets the parentheses. So, Carlos, you were going to tell me, what number would I have to put right here so that the inside only worry about the inside, what would I have to put in so that the inside equals 0? Just 0, yeah. There's no such thing as positive 0 or negative 0, it's just 0. Yeah, just 0. Since there's nothing in there with it, you would plug in 0. And the y value of the vertex is found exactly the same way as it is for absolute values. It's whatever number has been added or subtracted to the far right, and that number would be big old goose egg, Zippo. There we go. because there is no fraction on the front, you just move to the left one or move to the right one. So we will plug in either -1 or +1. It doesn't matter. I don't like to goof with negative numbers if I don't have to, so I want to plug in +1. The red one is me plugging in +1. And just like you saw me do with the 3's a moment ago, order of operations says I have to handle this exponent first. So I have to square the 1. And when you square 1, you get 1. And -1 times 1 is -1. And the great thing about these things is that their y values have to match because they are symmetric. So we plot those two dots, and we can sketch graph P. Drop a P on there like that. And we've done the first part. Because of the exponent is what made it U-shaped. It has to have the bars, the straight up and down bars, to be V-shaped. Exponents make things curvy. For now, the exponent of 2 is the only exponent I will show you. So yes, every time you see an exponent of 2, it will be a parabola. For now, okay? If it's a 3, it's not a parabola, it's a completely different shape. We'll get to those in chapter 4. Okay? All right, so the parent function. All 3 parent functions go through 0, 0. All 3 parent functions go through 1, 1. U-shaped graphs are symmetric. Whoops. And the red graph is different one way. I just need someone new, someone that hasn't talked to me yet, because I am trying to learn some names. I mean, I appreciate my people who are normally talking to me. I really do appreciate it, but I need to know everybody's names. Jan, you never talked to me. I know your name, but you never talked to me. Can you tell me what I'd have to do to the red graph to get the blue graph? And you don't have to use academic vocabulary, just describe it to me. Flip it around. Now, let me ask you this. Would you flip it left and right, or would you flip it up and down? Yeah, I'd have to flip it up and down. So the academic vocabulary for flip up and down is reflect. And when you reflect, am I reflecting over the x-axis or reflecting over the y-axis? We're reflecting over the x-axis because we're treating this line as our mirror. So you would say reflect over x-axis. Thanks, Jan. Appreciate you. Reflect over x-axis. And then one more. It's another straight line. Just says -x. Because there is nothing written to the far right, our y-intercept is 0. And the number in the front, just like it was here, is going to be a -1. But it needs to be a fraction, so let's call it -1 over 1, remembering that when the slope is negative, you don't say both the top and the bottom are negative. You pick one. I like to choose the top. That's just a me thing. So that says go down 1, go right 1. From here, go down 1, right 1. And then connect your dots. This is the graph of function P. And now we just need our parent function. The straight line parent function. That's good. That's good. He's good. He's good at drawing straight lines. That's perfect. There's our parent function. The red one is our parent function. And I'd be looking for somebody somewhere, virtually or physically, somebody new, hopefully that hasn't talked to me yet, would be fantastic. Tell me one thing they could do to that red graph to make it be the blue graph. I appreciate you helped me already. What's your name? Jason, can you tell me one thing I could do to that red graph to get the blue one? Meaning, when you say turn, what do you mean? So you could rotate that line, yes, and if this was a geometry class, I would be writing that on the board right now because technically that's a right answer. But in algebras, we don't rotate, and here's why. Mathematics that you guys learn about in high school, we care about functions, right? So let's take a parabola shape and allow me to rotate it. Now it's not a function anymore. It breaks the vertical line test. So that's why we stay away from rotations. Rotations are something that we really only do in geometry. I know, but we like rules that always work. So we completely avoid rotations in algebra. I know. So could you tell me something else you could do rather than rotating it? He's stumped. Anybody else? What's your name? Bryson. What else could we do? He says flip it over the y-axis, which I'm going to use academic vocabulary. Reflect over the y-axis is a perfect answer. Reflect over y-axis. Who said that? Bryson says, couldn't I just reflect it over the x-axis as well? Yes. Once again, the straight line has offered us two different perfectly correct answers, which is why I generally don't like to transform straight lines. Yes, Bryson? The red line was just the parent linear function. So the red dotted line every time is just the parent function. It's a great question. So that's it, guys. What do we think? Good? That's exactly what I'm looking for in the homework, folks.
A question, how many questions are on the homework? Or how many do we have to do?
Well, you have to do all the questions I assigned, but I think it's only